Tangent. Just like sine, cosine, secant, cosecant, there's going to be a pattern. You don't have to remember the pattern. You can always plug the values in. But if you remember the pattern, it's the same thing over and over again. It just gets shift left, right, up, down. All right. The other thing about tangent and cotangent is the period is a little bit different. Now, some people care about why it is, why it isn't. I'm going to give you a little short version of why it happens, and then if you want a longer version, ask me when we're done. So let's just take the y value of 1/2. So here is a y value of 1/2. That happens 2 different times, right? So it happens right here at 30 degrees, and then it happens again at 150. So if we went from 30 to 150, this is how far we went. Okay, that distance right there. Well, in order for 1/2, the y value to be 1/2 again, we go from here to here. So is that distance, is that green and that blue distance the same? No. So it doesn't happen. So it happens at 1/2, y equals 1/2, and then here. So it doesn't start repeating until we make a full rotation. Then it's the blue distance apart and then the green. The blue and then the green. Okay? With tangent and cotangent, okay, let's think about tangent and cotangent. I like picking this one because when we do y over x or x over y, it doesn't matter, it's 1. Okay? So it equals 1 right here. And this, if we do the tangent or cotangent there, it equals 1 right there. So now, if we go from here to here, that's a certain distance. Or if we go from here to here, certain distance. Is that distance the same? Yes. So what happens is the 1 happens more often. So the 1 happened here and it happened here. So there were 2 equal things that happened in one full rotation. Whereas sine and cosine, secant, cosecant, it doesn't happen that way. So again, if you like to know why, this first statement right here, the period of tangent and cotangent is 180 over b, or pi over b, that's why. Because there is something that repeats more often. It repeats twice in one full rotation. So therefore, 1 period happens every half a rotation. And half a rotation is 180 if we're in degrees, or pi if we're in radians. Okay? If you don't care about y, that's fine too. You just memorize, that's what it is. Now today it's going to be easy because you're just doing tangent and cotangent. But when you're studying for your test next Tuesday, now they're all mixed up. Now some periods are 2 pi, some are pi. So you're going to have to remember that. This next little part right here is just kind of something to make you think. It's kind of working backwards. We had that in the sine and cosine section where it said, or secant, I think it said like cosecant of what angle equals 1, 0, -1, undefined. So same thing here. This is just going to help us plot our points in a minute. So if we think about our unit circle, going back here, I already saw this, is we want to know where is y over x equal to 1. Well, y over x equals to 1 right here and right here. Both those x and y values are exactly the same. So the answer to that question is lots of different things. We could say pi over 4. We could say 45 degrees. Down here in quadrant 3, that's 5 pi over 4. 225 degrees, lots of different. We could do any coterminal to that also, positive or negative. Lots of different possibilities. We do the same thing. Look at that unit circle. Where is y over x equal to -1? That's going to be over here and down here. So we could say 3 pi over 4, 135 degrees. 7 pi over 4, 315 degrees. We could go negative pi over 4, negative 45 degrees. All of those angles are coterminal. So they would all make that true. Tangent of 0. Remember, we are y over x. So wherever we have 0 over some number other than 0, only place that happens is quadrantals. In the quadrant, there's not a 0 anywhere. It's only on a quadrantal. So we're looking for where is y equal to 0. Y is equal to 0 over here on the right and on the left. Bless you. So that's 0 degrees, 0 radians, 2 pi, 360 degrees, pi, 180. The positives or the negatives, we could go in either direction. All of those are equal to 0. Lots of choices. And then should there be asymptotes? Well, again, y over x. Is x ever 0 on the unit circle? Yes, x equals 0 up here at the top, and x equals 0 down here at the bottom. So there are places where x is 0, so it's going to be where x equals 0, because then the denominator equals 0, which makes it undefined. So for this particular one, so it would be, we could say at 90 degrees, pi over 2, 270, 3 pi over 2, we go the other direction, negative 90, negative pi over 2, negative 270, negative 3 pi over 2. All of those places it's undefined, because remember it goes on and on forever. If we were to, we could keep saying asymptotes. We could keep going 180 degrees away or pi radians away. So all of those things are from Unit 1 pretty much. These right here, using that unit circle. So now we're going to use that to graph it. Just like everything, we have y equals a tangent b theta minus c plus d. The directions tell us degrees because there's no c value that shifts, so the directions have to tell us. You will never get to pick. We will always either tell you or you have to know. If you think, I'm going to pick radians because I like it better, I like degrees, I like it better, don't use that, okay? Maybe you get lucky, you got a 50-50 chance of getting it right. It's either in the directions or there's a shift, a horizontal shift that will tell you. All right, now one thing about tangent before we start graphing it is we like the tangent and cotangent graphs to look similar. Okay, it just makes it easier to kind of understand when we graph one cycle. So with tangent, it's the one trig function where when we start our c value, we start in the middle. So we're going to put our 0 degrees in the middle. And in a minute when I show you on the calculator what that looks like, you'll see why. You don't have to, but then you're like you just have a part and another part, and then you forget about asymptotes and you draw things that are incorrect. So this just makes it a little bit easier to understand when we're just drawing one cycle. Then our period, remember we're tangent, period is 180 over b, b is equal to 1, so it's just 180. Now that doesn't mean from the middle we go 180 to the right and 180 to the left, because now we've gone 360. It's still start to finish is still 180, so we need to go half of 180 to the right and half of 180 to the left, because our whole period is 180. So we have to go 90 to the left and 90 to the right, and then since that middle number is 0, these are easy to find. We could go ahead and draw our y-axis. Our a value is our vertical stretch or shrink. It's not amplitude anymore, it's vertical stretch and shrink. So we know we're going to have 1 and negative 1. And then thinking about all those values, we don't have to redo this. We just did all that stuff right there. So first of all, let's look at, what's that first number? Negative 90. So where on this sheet did we write negative 90? Well, down here we wrote negative 90. And that's where an asymptote's going to be. So I'm going to draw an asymptote right there. And then where did we write negative 45 degrees? Negative 45 right here. So tangent of negative 45 equals negative 1. Tangent of negative 45, I'm going to plot that point.
Do you just have to memorize this? Look at the unit circle to solve this?
Well, I'm going to show you yes and no. Okay. Two different ways. You can either memorize the pattern, or you have to use the unit circle. Just like sine, cosine, secant, cosecant, you can memorize what the pattern looks like and just know the pattern, or you can plug these values in every time. We're not there yet. Okay. All right. So then the next one is 0 degrees, tangent of 0 degrees equals 0. So I'm going to plot that. And tangent of 45 degrees, wrote that over here, tangent of 45 degrees equals 1. 45 degrees equals 1. And then 90 happened in our asymptote column also. So we have an asymptote. Now, I don't want you to get your calculator out, but if you were to graph y equals tangent of x, that's what it looks like. It repeats over and over again. So it's got that little like curve, asymptote, curve, asymptote over and over again. This little middle section is what we're graphing right there. So notice the middle 0, 0 right there. That's why we started our C in the middle, because that's one full cycle, not a half of one and an asymptote in the middle and then the other half of one, and you have to know whether it goes up or down. Okay? So what this looks like is we approach the asymptote, and then we go through those 3 points, approach the other asymptote. And we do have arrows because it does go up and down forever. Approaching the asymptote. Be sure you approach your asymptote. If you don't approach your asymptote, you draw something like this. Okay? It's not right. You're not going to get credit for that graph. You have got to approach the asymptote. Towards the asymptote. And don't draw something like here and then go like this. I mean, don't be turning it. It's got to kind of go through those points. Okay? Don't do anything crazy. That is what a tangent graph looks like. That right there. Whenever you plot these 3 points, it starts down, low, then middle, then to the right, high. Those are the 3 points. The x-axis can be different, the y-axis can be different, but that's what the graph looks like. So you can remember what the pattern is for a tangent, or you can plug those x values, whichever one you want. It is up to you. If you can't remember if this point is down here or up here, plug that number in, and then you do have to use your unit circle for that. And now, is it continuous or discontinuous? What do y'all think? Remember, this is just one cycle of the entire graph, and there's asymptotes, so it is discontinuous. This one cycle is continuous, but we're talking about tangent. We can't graph the entire tangent graph. You'd never stop graphing. Okay? So the important part for tangent is your C value, where you start, is in the center. Now, if we do that same thing for cotangent. Now, cotangent and tangent. Tangent is y over x. Cotangent is x over y. So does y over x or x over y, is that going to affect what 1 and negative 1 is? Is that going to be any different? When I look at my unit circle, if I do y over x or x over y, that equals the same thing, right? So tangent of 45 or cotangent of 45 is 1. It's the same. So we could say 45 degrees, pi over 4. Again, there's lots of choices. I'm going to stick with those. Cotangent, same thing. We could be over in quadrant 2, 135, 3 pi over 4, negative pi over 4, negative 45 degrees, 315, 7 pi over 4, lots of coterminal angles that we have there. Just pull those off your unit circle. Now, 0 is different because cotangent 0 is x over y. So our 0 needs to be the x value, and when we look at our unit circle, there's x is not 0, but up here and down here, x is 0. So that's plus or minus 90 degrees, plus or minus pi over 2, 270, 3 pi over 2, any of those. So the 1 and negative 1 are the same, but everything else would be different. Same thing with asymptotes, because now it's x over y. It's wherever the y is 0, and the y is 0 at 0 degrees, 0. Plus or minus pi, plus or minus 180, plus or minus 360, because I could go either way. Again, I'm just listing a bunch of different possibilities. Never would you list all those. You couldn't just keep listing them. But any of those would be considered undefined, which would cause asymptotes. So same thing here, A, B, C, and D. A is 1, B is 1, C is plus or minus C, so there's nothing there, so it's 0. D is 0. Cotangent goes back to the left. Tangent's the only one that starts in the middle. So we're going to start at 0 degrees because it tells us degrees. Remember, our period is 180 over B, and B is 1. So we can just add 180 to 0. It ends up, the period is at the end because we started at 0. And then we can find the midpoint, midpoint, midpoint. Our y-axis is at 0. All right, so now we look at those values again. We're going to use this information. We can use that every single time, memorize using our unit circle, or there's going to be a pattern again. So 0 degrees causes an asymptote. Some people like to draw a solid line at 0 if there's an asymptote and then do that at the ends if that's something you like to do. I've seen that happen before because they don't like that asymptote and the y-axis are in the same place. You got to have them both. Then at 45 degrees, it's 1. At 90 degrees, we're at 0. 135 degrees, we're at -1. 180, there's an asymptote. Looks very similar to the tangent graph. We have asymptotes on the edges and then 3 points. It's just those points are flip-flopped. And that is what a cotangent graph looks like. Looks like a reflection of the tangent graph.
Why on the cotangent graph is the 0 on the end?
Because if we were to graph it, so again, we're just graphing one cycle. So for tangent, if we start at 0, which we like our parent functions always start at 0, 0 happens to be in the middle. So like if I only looked at that, we've done that before, and a lot of people don't remember what to do. Like they don't remember what. So if we show you that this is what a cycle looks like, for tangent we start there. But if I do cotangent, there's the cotangent graph. Notice that cotangent doesn't go through 0, 0. So now we're back to, we can see that one full cycle. Okay? I mean, you don't have to. It's just we have found that it makes it easier to remember if those graphs kind of look similar to each other. So everything starts at the beginning. It's tangent, the ones that shifted over, so that because of where the asymptotes fall, we can see it correctly. All right, and then it is also discontinuous because of those asymptotes. So the cotangent just looks like a negative tangent because those would be reflected over that middle. Now on your homework, some of the questions, I think the question is, what is the center? Okay. Well, if I ask you what is the center for this one, the center would be x comma y. So the x value is 90, the y value is 0. So when it asks for the center, all it's asking is for that coordinate point. Okay. The center is just literally what is the center of that graph as a coordinate point. All right, so this is the parent function, but with a 5 there instead of a 1. Okay? So 5 tangent x versus tangent x. All that changes, first we're in radians, so this is 0, not 0 degrees, and it's tangent, so we start in the middle. Period is going to be pi over b, which is just 1. Now, we don't go pi and pi because that's 2 pi. We go half a pi and half a pi, and together that's a pi. So half a pi and half a pi, and then halfway in between. When that middle is 0, that makes it pretty easy because everything's just plus or minus. We remember the pattern. We have an asymptote, an asymptote. Its tangent, I always plot my middle point first. I mean, you don't have to, you can do whatever you want. But our vertical stretch or shrink, that's that 5 right there. It's not considered an amplitude. Only sine and cosine have amplitude. So I plot my middle point, and then I just remembered tangent goes right and up, left and down, and there's your graph. Oops. Again, be sure to approach those asymptotes. Two values where it's discontinuous, we could say x equals plus n minus pi over 2. Now remember, those are not the only places where it's discontinuous. If I said list 3 places that are discontinuous, we would just have to add another period to that, so another pi. So another place that would be discontinuous is plus another pi. So at x equals 3 pi over 2, or another pi, you can go from there. All right, 2 tangent 3 theta. So now we have a vertical stretch, and we're going to have a period change. We're in radians, so the center's still 0, but now our period is pi over b, which is 3. So our period is 1/3 pi, or pi over 3. Remember, we don't go pi over 3 left and right, because then we've gone 2 pi over 3. We go half of pi over 3. So how do I know what half of pi over 3 is? Well, times 1/2. Now I know. It's pi over 6. Okay? So pi over 6 to the right, pi over 6 to the left. You divide something by 2. That's how you take half of it, or you multiply it by 1/2. Dividing by 2 doesn't make sense when I have a fraction. Multiplying by 1/2 does. The reason I multiplied by 1/2 because I got to go half the period one way and half the period the other. And then if I want to know halfway between 0 and pi over 6, I take half of pi over 6, pi over 12, and negative pi over 12. Asymptote, asymptote. My y-axis at 0, my vertical stretch is 2. I don't care how far up and down you go as long as 2 is above 0 and negative 2 is below. It's tangent, so here's my middle point, right and up, left and down, and then you can draw your graph. The two places where it's discontinuous is at theta equals plus and minus pi over 6.
So is pi over 6 actually undefined?
In this problem. Okay. All right, so this problem said tangent of x, right? So 5 times the tangent of pi over 2. Because we said a second ago, it's a very good question, that the only places where tangent is undefined are all those places down there, right? But now we're saying it's at pi over 6. Well, this problem, tangent of pi over 2, that's 5 times what? 1 over 0? Undefined. If I plug it in, 2 times the tangent of 3 times pi over 6. Am I taking the tangent of pi over 6? Am I doing the tangent of pi over 6? I'm doing the tangent of 3 times pi over 6. So now when I plug that in, 2 times the tangent, 3 pi over 6 is pi over 2. 2 times 1 over 0 is undefined. So it's going to change. It's just like if you had the parent function of a line, y equals x. You have the point 1, 1, 2, 2, 3, 3. But that doesn't always happen because if I change it to y equals 3x, now 1, 1, 2, 2, and 3, 3 aren't points anymore. Okay? When you plug in 1, you don't get 1. When you plug in 1, you get 3. And when you plug in 2, you get 6. So when we plug in these angles, when things start changing, that's why our x-axis changes, but it still happens at the same place. We are not taking the tangent of pi over 6, because the tangent of pi over 6 isn't undefined. The tangent of 3 times the angle, that is what's undefined. So that's why If you don't like just knowing the pattern and you're more like, I want to know why that is, then you would plug the values in each time. Because we don't know what tangent of pi over 12 is, but we do know what 2 times the tangent of 3 times pi over 12 is, because then it does end up on the unit circle. Pi over 12 is not on the unit circle, but when we plug 3 times pi over 12, ends up to be pi over 4, which is a point on the unit circle. And that will always happen. All right, cotangent, and now we have a horizontal shift. Cotangent goes back to starting at the left. So that's going to be left 50, or we could say we start at negative 50 degrees. And then our period, we're in degrees because there's a degree symbol here. So our period is 180 degrees over 1. B is the number between the word and the variable representing the angle. So we add 180 to 150 to get to 130. And this is where you could divide 180 by 4 and add, or add and divide by 2. So what is that? 80 divided by 2 is 40. All right. Negative 10 divided by 2, negative 5. 170 divided by 2, 85. Or we could have done 180 divided by 4 and got 45, and then just added 45 each time because there's 4 equal sections. Y-axis goes at 0. We just have an up and a down one. We can put in our asymptotes. Again, our asymptotes don't happen at cotangent of 130. It happens at cotangent of 130 plus 50. Cotangent of negative 50 plus 50. That's what causes it to be undefined, that particular function. That function's always changing. And then cotangent, start in the middle. Cotangent goes left and up, right and down. And there is our cotangent graph. Looks like a reflection of a tangent graph. So if I were to make that negative, those high and low points would flip-flop, and then it would look like a tangent graph. So a negative cotangent, or a positive cotangent, is going to look like a negative tangent. And a negative cotangent is going to look like a positive tangent.
Will there ever be a case where the asymptotes are at the very beginning and very end of the
Only if you do something like wrong with your x-axis points. But we want to see those 5 critical values. So as long as you do your critical values right, that's where they should end up. Okay? If they don't end up there, then you've done something wrong with your critical values. Or you just have to graph, like if we say graph one cycle, the reason, and for cotangent it wouldn't matter, but for tangent, like if you happen to start at the beginning instead of the middle, then your asymptote ends up in the middle, and then you just got to figure out what does it go up or down, and where does it start and end, which just makes it a little more difficult. And then the 2 values where it's discontinuous here, theta equals 130 degrees and negative 50. All right, so now there's everything being done. Once again, if you don't like that -3 out in the front and you want to move it to the back so that you have your A, B, C, and D all in order, because it makes it nice, you can do that. You don't have to. It doesn't change anything. Just don't make that -8 cotangent out in front, because that would not be correct. All right, so it's cotangent. Cotangent starts on the left. So we're starting at -20 degrees. Period is 180 over B, which is 2. So it's 90. How did I know to use degrees when it didn't tell me? C tells you. If there is a C value other than 0, you will know. If there's a degree symbol degree, if the degree symbol wasn't there, now we're in radians. That's how you know. So I'm going to add 90 to -20 to get me to 70. Then I get 50 divided by 2, 25. 95 divided by 2. Maybe I don't know what 95 divided by 2 is without, and I don't want to do the math. 95 over 2 degrees. You don't like that? You like 47.5? Fine, it's the same. 95 over 2, 47.5 are equal. 25 plus negative 20, 5 over 2 degrees or 2.5 degrees. I do not care. Now, I do care if you would have said 50 over 2 degrees. I would care about that. That's going to be a point. But when it's an odd, you can leave it like that or make it a decimal. But if you make it a decimal, make sure it's right. If you have 95 over 2 and then you do it wrong, now it becomes wrong. Up to you what you want to do. Y-axis goes at 0. Now our middle is down at negative 3. I like making a dashed line. You don't have to. Our vertical stretch is 5, so we just need to be sure and go up to 2 and down to negative 8. I will tell you that these, the closer you keep your high, middle, and low points right here, kind of your, not really high, middle, or low, but those 3 values right there, the easier it is to graph. The further away they are, the easier it is to kind of snake through those points correctly. Then we have asymptotes. Again, negative tangent or cotangent of 70 is not undefined, but negative 5 cotangent 2 times 70 plus 20 degrees, that is undefined. We plug in 70, 70 plus 20 is 90, times 2 is 180. Cotangent of 180, x over y, undefined. Cotangents, I always just plot my middle point first. Doesn't matter which point you plot first. If you can't remember, now I don't know whether to go high or low, it's a negative, I have no idea what to do. You got to plug in 2.5. If you do remember cotangent, cotangent goes left and up, but it's negative, so it's reflected down. Cotangent goes right and down, but it's negative, so it's reflected up. So a negative cotangent looks just like a positive tangent. Be sure you approach the asymptote and not that y-axis. Approach the asymptote, not the y-axis in this problem. 2 places where we're discontinuous. Theta equals negative 20 degrees and 70 degrees. I could say list 3 values where it's discontinuous. Since the period's 90, we'd have another discontinuity plus 90 right here. We could say 160. Or we could subtract 90 over here. It doesn't, but it could say that. And the last one, tangent. Once again, you want to move that minus 2 out to the end so that you can see your A, B, C, and D values. That works. Tangent starts in the middle. So I'm going to put that negative 1 there right away so I don't forget. There's no degree symbol, so we're not going to put a degree symbol on it. That means our period is pi over 6. I can't divide fractions, so I multiply by the reciprocal, and I get 6. The whole thing is 6, start to finish. So add 3, subtract 3. Negative 4 to 2 is what's 6. Not add 6 and subtract 6. Now you've made your period 12. 2 times too big. If you want to go ahead and put your asymptotes in there right away, you can do that too. The order you do all this stuff in doesn't matter. Now we can't put our y-axis yet because we don't know where's positive and negative. So we add, we get 1 divided by 2, 1/2 or 0.5. Negative 5 divided by 2 or negative 2.5. Decimals and fractions, one is not more simplified than the other. I do not care if you put 0.5 and negative 2.5 or 1/2 and negative 5 over 2. It's up to you. And then we move down 2. So negative 2. If you want to make that a dotted line, I like making it a dotted line so I don't forget. And then up 4 to 2 and down 4 to negative 6. Again, no matter what, you're going to start wherever you want. I like starting in the center. Tangent is right and up, left and down. If I don't remember, then I have to plug that value in. I have to plug a half in, multiply by pi over 6, and then find the tangent of that. Or remember the pattern. And we are discontinuous at theta equals -4 and 2. Now remember I said this earlier, but I'm going to say it again. The homework asks for what is the center. Okay, the center for this one would just be -1, -2. This is the center. Graph should have gone through that right there. There is your center point. Ask for the vertical stretch and shrink. That's just A. So the vertical stretch and shrink on this one would be 4. Period 6. The horizontal shift would be -1 or left 1. The vertical shift would be -2 or down 2. Either one of those would be okay with me.